A little bit about something called microbes. And microbes are sometimes thought of as things that are microscopic living organisms. Some microbes can make you sick. You know, microscopic living things that can give you strep throat or an ear infection or bronchitis. Tatum? We sometimes use that term germ. But germ can refer to a couple different things. Specifically, what causes strep throat? A type of what? I don't know. No, not strep throat. We're going to talk about virus in a moment. Nicholas? Bacteria. So bacteria are one type of organism. They are living things. They are single-celled living things. And sometimes they cause disease, like pneumonia or strep throat or an ear infection or pink eye or lots of other things. But then there's another group of things, I'm going to say, things that cause certain diseases as well. And they're called viruses. And viruses are kind of in a weird category. Because sometimes scientists classify them as being alive, and sometimes they don't. So if you think back to what we talked about yesterday, that living things are made of cells, well, viruses are not made of cells. They're surrounded by a protein coat, but not exactly cells. Okay, and they also require energy. They are adapted to their conditions that they live in. They respond to stimuli. They have lots of other characteristics. Now, viruses on their own cannot reproduce. So let's say there's a flu virus. We call it influenza. Tiny little microscopic, even much smaller than a bacteria, a flu virus is, a single flu virus. Well, it can't reproduce on its own. Okay? It can't make 1,000 copies of it to infect lots of people. Okay? Unlike a bacteria. Bacteria can reproduce on their own, but viruses cannot. Do you know how viruses have, so where do more flu viruses come from? Anyone have any idea how there's more of them then? Tatum?
When people kiss.
Well, if people kiss, they could spread a virus from one person to another, but where are those viruses coming from if the virus can't reproduce on its own? James? No. The way viruses reproduce is they actually get into a cell, and then they sort of take it over. And they put their own DNA into one of our cells' DNA. And then our cells actually are taken over by the virus, and they start making more copies of the virus. And then eventually the cell becomes filled with viruses, explodes, and those viruses then spread to other cells. And they take over cells, take over the nucleus, inject their DNA, and that process repeats over and over again. So on their own, a virus can't reproduce, but it can sort of hijack other cells and use them to reproduce. So viruses are in this sort of strange area where sometimes scientists call them living and some scientists don't. So they're sort of in between. So that's kind of a little bit of a side note about what's alive and what's not. And what I want to do today is talk about this concept that's called spontaneous generation. Okay. And spontaneous generation is an idea that in sometimes non-living material could turn into something that is alive. And we're going to talk about this concept. Is it true? Can non-living matter somehow just turn into something that's alive? What do you think? Okay. James? Big yes. People, well, let's read about an experiment first, then we'll talk a little bit more about it. So this was an experiment done a long time ago, like in the 1600s or so, by a scientist called Jean-Baptiste Helmont. No, most people haven't. But Van Helmont was interested in this idea of spontaneous generation, so he did an experiment. This is one you can try out. So, his experiment, here's what he actually wrote. If you press a piece of underwear soiled with sweat together with some wheat in a jar, an open mouth jar, after about 21 days, the odor changes. And the ferment coming out of the underwear, penetrating through the husks of wheat, turns into mice.
So
Hold on. What is more remarkable is that mice of both sexes emerge. And these mice successfully reproduce with mice born naturally from parents. But what's even more remarkable is that the mice which come out are not small mice, not even miniature adults or aborted mice, but adult mice emerge. Van Helmont. So Van Helmont actually did this. He took some sweaty underwear, he put them in a jar, put some wheat in the jar, and he let it sit for 21 days. And like his writing says, what he observed was mice coming out of this jar. And so he thought that the odor of the sweaty underwear somehow interacted with the wheat, and the wheat changed into mice. And that's spontaneous generation. And what do you think about this experiment? Do you think if you took some of your sweaty underwear that's laying on the floor in your bedroom, probably at home, put it in a jar with some wheat, would it turn into mice? Probably not. What? So what do you think about this, Natalie?
I think Mike probably just climbed in when he wasn't around.
Yeah, I mean, he left it for 3 weeks. He wasn't observing it 24 hours a day. Most likely, mice climbed in. They maybe were attracted to the odor of the sweat and wheat as a source of food. And maybe they nested in there and then he observed them coming out. What was wrong with the way he set this up? One simple change could have made this experiment have a whole different result. Matt? What's that? Yeah, if he had covered the jar. So obviously they put some sort of covering over the jar. Do you think mice would have emerged? No, they wouldn't have. Okay? And then he would have known that it's not the odor mixing with the wheat causing the wheat to turn into mice. But like you guys said, probably mice were just attracted and climbed in. But that's the idea of spontaneous generation. This idea that sometimes, if conditions are right, non-living matter like sweaty underwear and wheat could turn into something that's alive, like a mouse. Now, that may seem silly to us, and you all are probably like, that's, no, of course the mice just climbed in there. This idea that you could get living things from non-living matter, but it actually kind of made sense with certain things that people observed. We'll talk about a couple of those things. One example, people noticed that if you had a piece of meat and you just kind of left it, after several days, living creatures started to appear on it. Things that you had never seen before, maggots. And so people thought that after a period of time, meat that's rotting turns into these tiny little worm-like creatures. That kind of would make sense with what they saw. Because they didn't see any maggots before. They looked carefully at the meat, there's no maggots there, and suddenly they just appeared. People saw that if you left some bread out, the bread started to sort of transform into this living, hairy organism, this living thing that was growing in the bread. But they didn't see it anywhere before. It just sort of started to grow there. They thought the bread, after a period of time, would turn into this stuff. They had some soup or broth that they left. After a few days, it started to turn color and become cloudy. It started to smell bad. If you ate it, it would make you sick. There were tiny microbes, living things in that broth. And people thought the broth turned into those. Every spring, people would notice that near streams, lakes, and ponds, frogs would just emerge from the mud where they hadn't been for months. So they thought that in the springtime, the mud turns into frogs. Are there other explanations for these things? Does the meat actually turn into maggots?
No.
Where did they come from then? We'll talk about that in a minute.
That's so disgusting.
Does the bread turn into mold? No. There's mold spores floating through the air. When they happen to land on bread, then they start to grow. But the bread is not turning into them. This broth, this layer of microbes and stuff on the broth didn't turn into that. It settled there in the air. How about the frogs? Was the mud turning into frogs? Then where did they come from? They were hibernating deep in the mud over the winter, and then in the springtime, they start to emerge. But it wasn't that the mud turned into the frogs. All right, so we're going to talk about, hey guys, turn around please, James. We're going to talk about 3 different scientists that studied this concept of spontaneous generation. And we're going to look at their experiments and think about how they helped prove that spontaneous generation is false. So the first one is a gentleman named Francesco Redi. Francesco Redi lived in the 17th century. His research was focused on meat, on rotting meat. And the question he was trying to ask is, where are these maggots coming from? Everyone knew that if you left meat out, maggots would eventually appear. But his question was, where do they come from? And he had his own hypothesis. He had his idea, his prediction, that he tried to test in an experiment. Francesco Redi's experiment, his hypothesis was that these maggots actually are not coming from the meat, they're coming from flies.
So maggots are coming out of flies?
Well, let's look at the experiment and we'll figure it out. So what Redi did is he had a few jars, and in each jar he put some rotting meat. One of the jars was just left open with no cover. Another jar was covered with gauze, sort of like netting material. The third jar was completely sealed. And so Redi observed these jars over a few days, and he looked at what happened. So in the open jar, what Redi observed is that there were flies all buzzing around it, attracted to the smell of the meat. They would go into the jar, they would land on the meat, laying their eggs, and he saw that after a couple days, maggots would appear. Could anyone guess what happened in the second jar that was covered with the gauze? Kind of?
The flies were dragged on top of the netting.
Yeah, the flies were still attracted because air could get out. They could still have the scent of the rotting meat. But they couldn't get to the rotting meat. But they did land on the netting. Do you think any maggots appeared in that rotting meat? No. But they did appear on the screen. In the sealed jar, there were no maggots anywhere. So what do you think Francesco Redi's conclusion should be about his hypothesis? Nathan?
If you use meat, like,
So his hypothesis that maggots come from flies, was his hypothesis correct? Yeah, it was correct. Maggots do come from flies. What are maggots? Well, they don't look like flies. Nicholas?
they're like these like little like tiny like worm things.
They look like tiny little white worms.
Like kind of they're kind of like the same color. Like if you ever tried to kill a fly, like inside a fly looks like the same color.
Okay. So just like a caterpillar metamorphizes into a butterfly, a maggot metamorphizes into a fly. It's a baby fly. That's what maggots are. They're flies. Adult flies lay eggs, they hatch into maggots, they consume lots of food for energy, and then they change into flies eventually. So yeah, maggots come from flies. If you ever, like sometime in my house, we have like our big garbage that we take to the road, and sometimes if we put like meat in there and we didn't seal it in a bag or stuff, sometimes flies will be buzzing around, sometimes they lay eggs, and maggots hatch. It's really gross. Sometimes you open up the lid of the garbage and there's maggots all crawling. James?
You know, we just say broth too much.
Yeah, yeah. Is that it? Okay. Kind of?
Like after Halloween, me and my brother took the pumpkins and smashed them in the road, and the next day you couldn't even see the pumpkin because there's so many maggots.
Crawling with maggots, yeah. Yeah, flies will tend to lay their eggs in an area where when the eggs hatch, the maggots are going to have lots to eat. And so that's why sometimes if you see like a roadkill or something, they have maggots on it because flies lay their eggs there, and that's a good source of food. Maggots only eat decaying flesh, really. And we'll talk more about them eventually. All right, let's move on to another Italian scientist who did his work in the 1700s. Lazzaro Spallanzani was studying broth and the microbes that cause it to spoil. What is broth? Haley?
It's stuff that's in soup.
Yeah, it's like in soup, the watery stuff. How do you make broth? Like at home? Like if you want to make chicken broth, you want to know what it is? Haley?
You go to the store and buy it.
No, you want to make it. I said make it. Abby?
I think you just put water in a pan and then put chicken parts in it.
Yeah.
And let it
A lot of times after people like will eat like roasted chicken for dinner, they'll take like all the leftover bones and meat that was on it. They put it in a pot of boiling water, boil it for a few hours, and all like the meat and the other parts of the chicken that are edible all sort of dissolve, and then they get rid of the bones, and you have chicken broth. So broth was a common source of food for people. And like I said earlier, people noticed that if you left broth out, it started to turn cloudy, smell bad, make people sick. It was being somehow, these microbes were forming inside of it. And they want to know where they come from. So Spallanzani did an experiment. He had a hypothesis. His hypothesis that the microbes that were making the broth spoil, it wasn't the broth that was turning into the microbes. They actually came into the broth in the air. So he set up a pretty simple experiment. He made some broth, and he put it into 2 different flasks. He heated the broth, very hot, so it was boiling. Then he allowed it to cool. In one of the flasks, he left the top open and just waited. What he saw was that microbes started growing in there after a couple of days. In the other flask, again, he put the broth, heated it up, but then as soon as it was done being boiled, he sealed it. He put a cork in it so that no air could get in, and then he waited. And that broth did not spoil for a long, long time. In fact, it didn't spoil at all until he opened it, and then a couple days later, it spoiled. So that was the experiment he did. So what do you think his conclusion should be? His hypothesis is that the microbes were coming in from the air. Gavin, was he correct?
Yes.
Yeah, he was, because as long as he kept the air out, the broth didn't spoil. Only after he opened it up, exposing it to air, did the broth spoil. So yes, microbes come from the air. Well, why didn't the boiled and sealed flask, why didn't microbes grow? So why didn't any grow in this flask for a while? Adam?
Nothing to get in it.
Right, but why didn't the broth turn into it? Or what about microbes that may have been in there before? Zach?
Because no air could get in the container.
But it got in here, right? There's air getting in at this step, because it wasn't sealed from the beginning. So what happened there? Bailey?
He heated it.
Yeah, what happens when you boil something in terms of any microbes that might be in there? Yeah, it kills them. Has anyone ever canned anything at home? Like tomatoes or made jelly in those mason jars? Anyone, parents have done that? Has anyone seen their parents do that? Or? Okay. What do you do to those jars and lids before you fill them and seal them?
Clean them.
How?
Boil.
You boil them. You have to boil all the jars first, then you can put your, whatever, tomatoes that you're canning in there and then seal them up. Why boil them first?
And they have time to clean.
Yeah, to make sure no living bacteria are there. Because once you've boiled them, if you can keep the lid on there, that's why those canned goods stay fresh for a long time. Because there's no bacteria that can get in there. If you heat things to the proper temperature, the microbes die. That's why you're supposed to cook your meats to certain temperatures, and why you're supposed to boil things in order to get rid of those bacteria. Because they can't withstand high temperatures, boiling temperatures. And now we have one last scientist who took this research one step further. And his name may be familiar to you. We'll talk about it in a minute, why it's familiar. He was a friend, oh, I'm sorry, here, and also it was sealed as well. Besides boiling it, then it was sealed, that's why no microbes grow. Now the next scientist is a French scientist. The last two were Italian. His name was Louis Pasteur. He was doing his research in the 1800s. And again, he was answering a question similar to what Spallanzani was answering. Again, where do these microbes come from? But Pasteur had a slightly different idea. So where did Spallanzani say the microbes came from? Kendall?
Air.
From the air. Well, Pasteur said, well, they're not just kind of floating on their own in the air. Actually, these microbes are on the dust particles that are in the air. That's what he thought. Have you ever looked at like a sunny window when the sun's streaming in and you see all those dust particles floating all over? Well, Pasteur said, on those tiny little dust particles, there are microbes. And that's what's carrying them into the broth. So he came up with a pretty smart experiment to test this. He used these special swan's neck flasks that had this S shape in them, this long, thin S shape. They were open at the end. So again, what Pasteur did is he made broth. He put it in the flask and heated them. Okay? Now, because of the shape of this tube that connects to the flask, air could still get in to this broth, but dust could not. Any dust in the air would get in, and then it settled in this sort of curve of the flask. So air was getting in here, but dust was not getting in here. So after he heated up, what Pasteur saw was he could wait a very long time, years, and no microbes would start to grow in here, even though air was getting in. But what he would then do is if he tilted the flask, and some of the broth got to some of the dust that had settled in there, when he tilted it back, then a couple days later, microbes formed and it was spoiled. Okay? So air getting in did not cause spoilage. But when it touched the dust, it did spoil. Microbes did grow. So what about Pasteur's experiment? What about his hypothesis? Was his hypothesis correct?
Yes.
Yes. And we know today that's where microbes are carried. They're not just in the air floating around on their own. They're on these tiny little dust particles. And so we know today, is spontaneous generation a correct theory? No. Living things cannot come from non-living matter. These scientists have showed us that through their experiments. Living things only come from where? Other living things. Life comes from life. Maggots came from the flies. The mold on the bread came from mold spores in the air. The microbes in the broth came from microbes on dust particles in the air. The frogs came from hibernating. So there are explanations for all those things that originally led people to believe in spontaneous generation. Related to this, and we'll talk about this in a minute. In earlier times, early Europe, people had noticed that if people drank water from some natural sources, it would sometimes make them sick. That it had microbes, bacteria in it that gave people illness. However, if they took that same water from that same source and used it to brew beer and drank the beer, it did not make people sick. They didn't get these same digestive illnesses, even though it was the same water. In fact, they even brewed lower alcohol beers to give to children because it was less likely to make them sick than drinking water from some of these natural sources. So why? So why did this water make them sick, but not the beer that was made with that water? Gavin?
Because from the water, it was just straight from lakes and oceans. So, but they had to put ingredients in the beer to make it
Okay.
taste like the water.
You're close, but it's not the ingredients that are important. Matt?
I looked at the picture, and there was a kettle, so maybe all the bacteria from the water from the water where they were getting, they started it would make the water cleaner.
I'm missing one little piece of information. Zach?
It was boiled.
Yeah, the process of making beer, you take the water, you boil it with malted barley and hops and so forth. And in the process of boiling it and then putting it in bottles and sealing it, you're doing the same thing that Pasteur and Spallanzani did. Okay? Because heating it up kills any bacteria, and then sealing it prevents any new bacteria from getting in. Now, they didn't actually have to make beer with it. What could they have done?
Made a different drink.
Gavin?
They could have just boiled the water.
Could have just boiled water. In fact, around your neighborhood, if there's ever been like a water main break and they think bacteria may be in the water, what do you have to do before you use any water in those situations? Yeah, boil it. It's called the boil water advisory. And if you're going to drink any of that water, you have to boil it first because it'll kill any possible bacteria that are there. Now, one more thing. Why is this gentleman's name probably look familiar to you? And maybe you saw his name this morning when you were eating your Fruity Pebbles, and your gallon of milk was there.
His son.
His son did not invent Fruity Pebbles. Pasteur.
It's like there.
Pasteurized.
Yeah, if you look at that carton of milk that you poured in your cereal, it's been pasteurized. What does that mean they've done to the milk? James?
They made sure there's no microbes in it.
How? What do they actually do to it, you know? How do they take milk from a cow and pasteurize it? I don't know.
They boil.
Yeah, they heat it. Sometimes they boil it, sometimes they don't. But they heat it to a temperature to make sure any bacteria die. And then what do? not just feeding it. Then you have to what?
Freeze it or close it.
Close it, seal it, right? And this is why a can of soup could sit in your cabinet for years and not spoil. But what if you open the top? Can you put it back in the cabinet
No.
and let it sit for years? No, because what's getting in as soon as you open it? Air, which has dust, which carries microbes. Good job. Perfect timing.
Are we gonna talk about spontaneous combustion?
Excuse me?
Are we gonna talk about spontaneous combustion?
No.